Hello and welcome to our fourth Design and Manufacture theory video. This one focuses on production planning. Now, we know how to make stuff out of metal and plastic and wood and so on. Production planning is less about the actual manufacturing processes and more about the ways in which we can, as designers and as the design team, make sure that the things we're building and producing are made as efficiently as possible. So that's where production planning comes in. Again, as you can see, this sheet probably looks worse than the last one. There's just a few key things that I just wanted to get in. Again, none of these will come up as more than maybe 2 or 3 markers, but it's important that you have at least a bit of an understanding about what they mean. So if we start at the top, just-in-time regards just-in-time manufacture. What that means is instead of just running the production machines and so on round the clock 24/7 with just-in-time manufacture, we stop the machines as soon as the amount of components that we require for that day are produced. Now, this means that we're not having to stockpile lots of excess stock in expensive warehouses, which can be really expensive due to them being climate controlled and maybe the security and just the actual buildings themselves to store this stuff that we don't really need to store. So that's the premise, I suppose. The negatives with just-in-time is if you do have a problem with, say for example, your machine breaks down, you don't have a stockpile of all these parts, which means that the entire system can shut down, which could be really, really bad in terms of not meeting deadlines for suppliers and so on. So in summary, you run the machine just until you've gotten the number of components you require, and then you stop. When we're talking about standard components at the top right, these are the components such as nuts and bolts, and even through to things like zips for a jacket, and they require specialist machinery to make these different parts. So it may be the case that you might be a furniture manufacturer, rather than manufacturing your own nuts and bolts. It may make much more sense just to buy these in. They're very, very cheap, and it means that you don't have to actually buy the machinery and then train the staff to use the machinery. So it can just be a far cheaper endeavor. The problem with standard components is you're relying on another company for the survival of your own company. So for example, if they miss a deadline and you don't have the stuff delivered, or the quality of the produce that they're sending you is just substandard, that can have a really bad impact on your own products. For example, if a shoddy bolt or several thousand shoddy bolts get sent out, you might send your chairs out into the world and they may develop faults which would reflect badly on your company and your brand. Another topic to think about in production planning is Gantt charts. Now, Gantt charts are a visual way of planning the jobs that are remaining to do in any given design task. As you can see on the sheet, it's split up just simply into task 1, task 2, task 3 down the left, and across the top you have the dates that each task is to be completed in. Now, the good thing about Gantt charts is that you can have many tasks spanning many months, and you can quickly see if there's any bottlenecks, any pinch points in the year where you might have to actually, like it might slow down production, or you might find that just as a glance at the Gantt chart, that there's something that maybe needs moved around because it's going to halt production. So it's just a visual way of planning out the year using usually a range of colours. They can be easily understood by all members of the design team, and it's good for pointing out any bottlenecks. Across the bottom of the page you see job, batch, line, cell and flow. Again, these are all production planning kind of theories, I suppose. They're hopefully fairly straightforward to get your head around. Job, in terms of production planning, usually refers to a one-off job. So as you can see there, there's a wooden seat with a leather seat pad. Now, if a designer was just commissioned to make one chair, that would be called one-off manufacture or job manufacture. If the designer instead was asked to make 500 chairs, the chances are that instead of just making 500 chairs from scratch start to finish, they might make all the legs at once, and then all the seat pads at once, and all the seat backs at once. This would mean that setting up jigs and so on, you weren't having to constantly set up and take down jigs. That's called batch manufacture. So you might have, say, 500 backs, 500 seat pads, and so on. These would all then be assembled at a later date. The reason for that is just that it is deemed to be a far more efficient way of working, rather than making 500 chairs individually from scratch. Line manufacture is something that you'll all be familiar with. Production lines, as you can see in how it's made and on TV adverts for cars and so on. The product itself runs along a conveyor belt, and a combination of either machines or humans or both add things to the product as it moves along. It's deemed to be a really, really efficient way of products moving around manufacture. Cell regards to a group of people known as a cell who are responsible for a certain part of production. The example I've used in the past is if you imagine a taxi, like a traditional London taxi. A production cell is perhaps responsible for the fit out of the internal fit out of the taxi, so things like the upholstery and the carpets and the roof material and so on that goes in, through to things like wiring the internal lights within the taxi cab. You might have seen on the inside of taxis, it sometimes has little plaques that say, built with pride by cell number, whatever it is. The idea behind that is that these teams know each other's skills really well. They take pride in what they do, and because they do the same thing all day, every day, they're highly skilled and very efficient at what they do. So a cell is a group of people that are tasked to do a limited number of production techniques or manufacturing techniques within a product. Flow deals with the overall movement of the materials and the packaging and the product itself around the manufacturing warehouse or wherever it's being manufactured. With flow, what we're looking for is for there to be no bottlenecks. Again, we can think of Gantt charts and so on in terms of making sure that happens or that doesn't happen. What it means is that we're looking for that efficient flow, so we don't have problems with components not turning up, or components with or problems with really any other aspect of the production process. So if you want, it's probably a good idea just to pause the video, have a wee think, test yourself. Do you know what just-in-time manufacture is, for example? Would you be able to explain the pros and cons of standard components and Gantt chart planning? Test yourself, and if the answer is no to any of these, then obviously rewatch the video and then do some further research online. Okay, good luck. Bye.